We're to Unit 2, Free Response Question 2. This one is a calculator question. And I posted a link on Classroom the other day to help you guys, if you don't have a graphing calculator, trying to get these problems done. It's been a little while, though. It was kind of towards the beginning of the school shutdown. But I reckon if you don't have a calculator, you need to download that to a computer in your house. So when you're practicing, you know you'll be able to do it. And I think probably by the time you are watching this video, the calculator situation will be sorted out with taking the test, because I do understand a lot of you don't have graphing calculators at home. So I feel like there'll be a calculator embedded into the program where you're taking the test. If not, it is going to be essential that you get that TI calculator downloaded onto some computer in your house. All right, so here's the problem. We have another graph of f. This time it's just 2 line segments. And then we have we are told is defined in continuous on that closed interval. And then we also have 2 other functions that we're going to have to do some things with. And then A creates a 4th function, which is k. And so we're going to find k prime of 0. K is just the product of f and g. So to find k prime, we are going to use the product rule, just like we did in the last free response question. Now when you're doing the product rule, don't put 0 in yet. Just go ahead and do it with x, because you will get a point for that. Then put in 0. Alright, so all the f of 0, f prime of 0s on this, we are going to get from the graph. And then the g stuff, we are going to get from the calculator. So for f of 0, we go to the function. When x is 0, the function is equal to 3. For g prime of 0, we're going to go to the calculator. And if we want to do, I'm going to just write some notes up here. G prime of 0, what I would do first is go to y equals and then type in what g is, because we have to use it more than one time, so this will just make it easier for us. I'm going to do that real quick while you guys are. Okay. Then go ahead and quit out of there, and anytime we want to use the derivative on the calculator, we do alpha window. And the derivative is number 3. Okay, so you get something that looks like this. I'm leaving some spaces because I'm going to fill them in a second. And so what we want to do in this place, we're going to put an x. All right, and then if we put this function into y1, we're going to hit y1 here. And to get y1, it's alpha trace. And then we need to put an x here and a 0 here. Now, if you forget how to get y1, if you can type this whole thing right here. It's fine. It doesn't really matter. But if you're using that function more than once and you're trying to save time, because this is definitely a timed exam, hopefully you can remember, or maybe go back and look at your notes. I don't know. At this point, though, we do not want to round to just 3 decimal places. Like at the end, yes, that is what we do. But in the middle of the problem, I would write these out, because your final answer has to be accurate to 3 decimal places. So if we round and round and round throughout the problem, then that is going to distort it. And so we would not be able, it's possible to distort it enough that you would miss the point because of the rounding in the middle. Okay, and then we're going to do plus g of 0. So if you all put that function g into y1 at this point in the calculator, you can just do y1 parentheses 0. And again, to get that y1, it's alpha trace. All right, and we're not going to round. We're just going to go ahead and write the whole thing out. All right, and then we're going to multiply that by f prime of 0. All right, f prime of 0 is going to be the slope of the line when x is 0, and the slope of that line is 2. All right, and then what I would do here is when I'm using these decimals that are already in my calculator, I would just pull them up and type it in all at one time. So hit 3 and then go up a couple of lines and pick that decimal, and then plus, go up a line, pick that decimal. All right, and then we'll sorry, I did something wrong. Okay, there we go. We would get this 2.598. And remember, we have to be accurate to 3 decimal places. You can truncate or you can round. This one, they would be the same thing, rounding and truncating. All right, so here's another one. So same problem, but this time we have a new function m, and m is using a quotient, so we will have to use the quotient rule to find m prime. So this is low d high minus high d low over low squared. Okay, go back and put in 5s for everything. Okay. And then let's figure these things out. So it's going to be 2, and then g of 5. Just to save on space, I'm just going to figure that out. So it's going to be 5 squared minus 5 plus 3. You could type that in the calculator, and so that's the square root of 23. Or you could get the decimal, it doesn't matter. And then for f prime of 5, we're going to go to the graph, go to 5, find the slope of this line. So it looks like it's going to be negative 2/3. All right, and then f of 5, we go, same thing, go to the graph though, and we want the value of this point, and that is 5. Right, and then 2 times g prime of 5. I'm going to let the calculator do that. So I already have g in my calculator for y1. So this is just like what we did last time. Alpha window, number 3, x, and then alpha trace, y, and then put 5 in. Again, we're not going to round, we're just going to go to all those places, just so I know in the end. In the end, I will be accurate to 3 decimal places. Okay, and then just type all that in the calculator at one time, pulling up previous things. Get the fraction by doing alpha y equals. And in the end, we're going to get negative 0.171. Okay, and then on this one, we are going to use h. So we're told that f prime of x equals h prime of x. Oh no, I'm sorry. We're going to find the value of x for when f prime of x equals h prime of x. And we're only using the interval from -1 to 2. So if I look at the graph on the interval from -1 to 2, what is f prime of x? It should be the slope of this line. And the slope of that line is 2. So I would take a second and I'd write that down. F prime of x equals 2 on the interval from -1 to 2. So it's always there. Always 2 there. Alright, so let's go ahead and find h prime of x by finding the derivative of h of x. This is not a hard derivative to do because we have e to the x, so it is its own derivative. And then the derivative of -9 sine of x is going to be -9 cosine of x. So we need to find where these two are equal. So to do that, in my calculator, for y1, I would put in 2. And for y2, I would put in 5 e to the x minus 9 cosine of x. And make sure that you are in radian mode. Okay, so the y equals 2 definitely is just a horizontal line. Alright, and then the 5e to the x minus 9 cosine of x, it looks like a cosine graph, and then it kind of curves up like exponentials. This is kind of cool, actually. So on just the -10 to 10 window, they cross each other 4 times. But we only need to find where they cross in this interval. So they only cross 1 time in an interval. So to find where they intersect, we're going to do... we are going to do second trace to get to the calc menu. And then we're going to choose number 5, which is intersect. Alright, and then because they cross 4 places, we need to make sure we move close to the point we're finding. So I just put my cursor right on top of the point I'm finding, and then you have to hit enter 3 times. Hold on. I found the wrong point. I'm sorry. Okay, so h prime of x equals 2 when x equals